Okay, hello everyone. I'm Xiaogang. Okay, we basically covered most of UObject. Next, let's reinforce the memory and expand a bit. Actually, it's quite simple. Just go through it once and then give it a paper pen read. Let's just go through the document directly. Then, for the factory method of UObject, it has several parameters. This outer is an external object, and classes is where you specify its class, what kind of object it creates. Then this gives you a pointer. Actually, let's just look at the engine source code. Just look at this. NewObject. Alter its name. This flag is quite important. Then this is templates. These templates, it can copy some information over template. That is whether it is copied from the CDO object, some temporary data information, etc. It also has some initialization of these tar sets, etc. Okay, basically, NewObject. That's roughly how it's used. It's much simpler than our spawn actor. The use case for spawn actor is more complex. Then, you can see here, there's also a way to directly pass an external object as a temporary package, something like a package. This part is for copying and judging. And here are some other objects. Detailed explanation here. This is a convenient template to construct a game object. This is an external object. If not specified, then it will be created in a temporary package. Then it's what type of object does it construct? This is its name. If not specified, a temporary name will be given. Usually this unique name. And this is the flag. That is what characteristics this object has. And this template is used to trigger this object. If not specified, use CDO to run. And this is whether to copy something from CDO. Yes, and this refers to some other settings. And this is an external specification of some external package to create it or something. Then this finally reflects a pointer. Actually, the more difficult part for us as the load object, this is something we often use in hard reload to load these things from the hard drive or from a pack file. Okay, that's all for this. Then take a quick look. And this is a newly created object. As for what it passes in, it should pass a template used as a reference. Yeah, just one more reference template. And then a constructed object. That's about it. The information you see is actually similar to what we see. Though the most important thing is to look at the object flags. You see, this kind of writing is very special. It marks them one bit at a time. It is something we will talk about later. It is a kind of, it appears to be a single value, but it actually represents multiple pieces of data. This way of writing is to save space. It can mark each one individually. I might not be explaining it very clearly to you right now. We will talk about it later. We will demonstrate that kind of thing later. So you can know that multiple flags can be passed here. Just mark them accordingly. And here, these are the properties. This means that if nothing references it, it will still be retained. Let's look at the website here. Okay. This object tag, this is a transactional object. Local object, not referenced. This is standalone, not referenced, but it will still be retained for public editing. Then these garbage collection ones. Then garbage collection, it will mark whether it is reachable. Also controlled through these. Then some lifecycle tag. Then some manufacturing tags. Okay, let's take a look at this new object and some of its application scenarios. I'll write out 2 pieces of code for you. Look at mine. I'll make this plugin disappear. I'll show you 2 sections. Just that it doesn't seem to be here. Then I'll just open my project directly. Shouldn't be a problem. Let's just open the project. Okay. Open 5.3. Open this GitLab. The project inside GitLab. This place. Okay. Let's see what else is coming up. What comes next should be. This chapter should be about done. We mainly look for things within the project. we often use the search function. This function is very practical. We believe that by limiting the reset position to MinimalAPI all might this be a bar 4 in Unreal Engine will also be covered later for everyone. We'll take one out and briefly explain it. It's relatively simple. For now, let's look for LoadObject below the current one. Right here, you can see here, we left a SunderVive. SunderVive is the audio object in our virtualization difficulties. Then we copy its data into it. We copy the audio's binary sound wave data into it. Then specify its frequency, its number of channels, its sample bit depth, and total duration. This way, the audio is dynamically generated. But you can also generate this audio after packaging. Use it in the game. When we did TTS, we used this code. And this is an application scenario for NewObject. One thing worth noting is that this code might currently have some issues because it seems like in 5.4.3, there's a bit of an issue with placing this. Other engine versions are fine. Let's take another look. Look at this spot. The NewObject here is used to create this blueprint node. Sometimes, when you look at blueprints like this, it has a delay symbol in the upper right corner. This is generally how it's done. Let me find it for you again. Let's search this way. Maybe we should look for it in the project. UObject. Let's search for it this way. Who would have thought it's not here? Because here possibly due to the reason of taking tickets from elementary and middle schools. It should definitely exist. This blue texture, it just leaves the texture out. Sometimes we have the need to take screenshot or record the screen or generate player avatars and then or we read from local storage. Dynamically read, not you dragging an image from the editor into it. The game has already been packaged. Dynamically read a local image. Then at this point we call it dynamic construction. Use tx_tar_d_c. This way it gives some tags. No name needed for the name. And this one is public. Public means it can be accessed externally. You can see this traction thing. This is the original tag. Add a 0 word to it. You can see. And this is 6RA, TXTRD. We often use TXTRD. We will explain later how to read data from TXTRD. Okay, so here we have basically finished explaining. And there is also a document here. Let's also take a look. This is the initialization of properties. Let's review. That is, if you native members wrapped by UProperty, if you do not initialize them, then it will help you initialize them. The same applies to structs. If it is a struct wrapped by UProperty, remember to initialize it, then update the reference. That is, if your actor or actor is referenced elsewhere, but you now want to destroy it. That is, destroy. It is the rule of its lifecycle, and destroy it. Then all other places, as long as they are pointers managed by UProperty. Include tmap. But this tmap of mine has UProperty attached to it. Then it can also detect that this object has been destroyed. It will automatically set this pointer to null. Then it can detect such a situation. If it is this kind of raw pointer, then I will demonstrate this problem for you. That is the garbage collection we demonstrated on site at the time. There it will cause this problem. And generally speaking, you don't have to scrape poverty, but depending on your needs. Anyway, if you don't need poverty, you can use this tweak object, but you can check the validity, usually in our editor, when deleting a resource. This situation also occurs, that is, when I delete a skeleton, but all references to this skeleton blueprint will still prompt you, either plan or delete altogether. For serialization, that is, we have some values that can be stored. Yeah, this is a serialized, that is, in the level blueprint. We instantiated two soldiers. These two soldiers, their initial health values are 50 and 100 respectively. Then these two values will be serialized and recorded, without us having to write code each time, to perform a table reading operation, to initialize this information in the scene. So that's roughly the situation. Now this CDO, right? We have demonstrated it. That is, if the default values of the CDO are changed, all instances will change along with it. But if these values have been modified by you later, then the value after your modification will be used. The CDO will not go to the values you have changed. will not update with you. So to put it plainly, this is a convenient approach for us to update property values. A convenient idea. Then editor integration. We can directly use these two macros to proceed, because these two macros define the factory for you, and they define how the variable attributes of each variable type are reflected in the editor. It is a float, it is a string, it could also be some options, some checkboxes to tick, but if it's a type that hasn't been defined, you'll need to write some factory classes yourself. This is quite common in editor development. In this case, it's a type conversion used at runtime. This is actually an upcast. That is, our actor derived the enemy class, and then boss inherits from the enemy class. Then boss overrides. Note that here it overrides the speak method. Then within the speak method, it calls the parent class's method. So it will first execute power-up, then call the parent class's time to fight. Therefore, it will print out these two lines. So this super is our go help us define. He defines his subclass as his super. In UE5, we can only this kind of U class or a class can only inherit all the way from here. You can also inherit some other interfaces, but you cannot inherit another. Inherit another U class or a class. So let's give an example. That is, in UE, we generally don't encounter this kind of multiple inheritance issue, because we usually only use single inheritance. You see, this A class only inherits one A class, and everything after that are just interfaces. That's the idea. Anyway, just keep an eye on it. Just watch out for those minor issues in C++. We'll cover this part later. No need to emphasize it here. Okay, so this is a usage. Let's emphasize our cast again. We can use an enemy pointer to point to a boss pointer to point to a boss object. This is completely fine. This is an upcast. Then if I won't create it here, it might get created for you. That's it. Then here, you can cast it over. That is, we take this pointer, cast to. The way it's written here might be a bit problematic. It shouldn't be written like this. That is to say, convert this object, this pointer into, if this pointer is successfully cast, that is, if this enemy is a boss. Then we execute the following. We can also use some specific classes of a certain type, whether it is a derived class of it. That's roughly what it means. Okay, then we'll talk about this later. This is relatively simple. Actually, it's the same as what you do here. It's the same as doing this kind of operation in your blueprint. Cast2 is this kind of operation. Okay. This garbage collection, we won't go into detail on this part. If you're interested, you can look up garbage collection algorithms. That is, you can adjust the garbage collection method, its GC timing, and these batch rules within this option. We can make some selections here. If you set this time very short, then the GC frequency will be very high. Each GC will cause a stutter, but this will reduce the heavy memory usage, because GC runs quickly. Anyway, these are just some algorithmic mechanisms of garbage collection, and generally we don't tend to modify this. Currently, we are at the introductory stage, so you probably know that it has these options that you can check off. Take a look. Anyway, it's just the literal meaning. You should be able to understand it by looking. Okay, and finally, network replication. When it comes to networking, we mainly use two methods. One is property synchronization. It synchronizes a variable from the server to the client. This is from server to client. It can only go in this direction. The other is RPC. That is, the client calls the server to execute. The server calls the client to execute. It can pass through. It is also implemented through these two red ones. We won't go into detail here. Okay, so basically, we have finished this section. We still have one top class left. As for the one top class we have left, actually, let me demonstrate it for you. Note that this TSubclassOf is a U-class type thing. Let's put it here. Let's erase it first. Put it here, okay? Let me see how it's written. It should be written here. You used edit defaults only. Yes, this thing is generally only usable in this editor. No need to change it on the instance. Here we write an edit default only. Then we top crop. Let me see how it's written. Yes, and this class is called MyUmpire. Well, it's better to paste one here. Pasting a UObject looks better. Well, let's see if we use it. You need to specify one of its subclasses. Let's see if it reports an error here. Okay, no problem. There should be a typo here. Yes, a spelling error. Okay. Then after you specify it like this variable can be used in C++ code. It can also be used in Blueprint code. This is a way of communication between Blueprint and C++. Regarding class variables, then we can see. What is this class? Let me check. It's base extra, right? It's class extra. We create a subclass of it. We should have created it here. Then here, you can see, here you can specify these two classes. This has a class type. Once you get this class, you can spawn it. You can spawn it in C++. You can spawn it in Blueprint. That's basically how it's used. Okay. So I can see my class. Let's just do it in the class default. Here, that's it. You take this variable and use it. Oh, here, because it's not Blueprint readable and writable. You can't yet. That means you need to use it in Blueprint. You still need to add something. So this is just a way to do it. Then let's see. It should be like this. Then let's go back to this place. Okay, let's open it. Should we be able to use this variable now? Hey, see that? It's purple. So with this variable, what do? Of course, we can spawn it, right? Okay, so it's just checking the spawn box here, isn't it? This is one usage, and its advantage is that it restricts it to this class in its class. Okay, well, there is also a class specifier here. Let's take a look at the class specifier. Actually, your class specifier, generally speaking, you only need to focus on these two. This can be used as a variable type in Blueprint. This can be used as a base class. If you write this, then Blueprint can create a class derived from it. If you don't write it, it won't work. Then these are some cost distributions. These two are the most important. These are the two we most commonly use. And abstract. You can see where it is abstract. We can search for abstract. Found it. You see, this node is abstract. This proves it is abstract. It just doesn't need to be instantiated or anything. It just defines a template or standard for you. It's not for you to instantiate. Then these are some groups. I won't follow along with this part. You can open the document yourself and quietly look at it for a while. Let me see which ones are more important. We often use some depots. They are deprecated. You can take note of that. This will cause bad things. I need to emphasize this, causes the export of type information for this class. Almost the module uses it. Functions of this class cannot be called. Note the sentence. Functions of this class cannot be called. This is a very bad thing. It's like sometimes some beginners, they don't know why to use MinimalAPI. They just use this thing, and then it causes, no matter how hard you look, you can't find this error. We can tell at a glance, always saying whether the red mark is written. Do you like MinimalAPI? Yes. Then take a look. These are rarely used, actually. Okay. Good. This is the metadata. The meta needs to be used within Manta. It is only used inside the editor. Just take a quick look. Whatever we use later, we will explain then. Good. Okay, sometimes interviewers like to ask you, what metadata tags have you used? Or something like that. You can take a look at it then. This bund is thread safe. It seems like an animation timroquant. There is a dedicated function for it. It is thread safe. Here you can simply understand that it is thread safe. If you write an animation blueprint, if you write it in one block, you might need this knowledge. Okay, so this UObject, UCast, UObject is now finished for everyone. Good. Thank you everyone. It wasn't easy.